Hello, today we'll read kinematics. Kinematics, what is kinematics? Kinematics is a branch of mechanics that studies the motion of a body without the cause of motion. Okay, it is a branch of mechanics that studies the motion of body without the cause of motion. Okay, now we'll describe rest. What is rest? We will say the body is at rest with respect to a definite frame of reference when, with the passage of time, the motion of the particle is zero. Okay, that is, with the passage of time, the body with reference to a fixed reference frame, it does not move. Okay, then what is motion? What is motion? Motion of a body with respect to a fixed frame of reference the movement of particle occurs with the passage of time. That is, a frame of reference is one thing when it is calculated with respect to time. Okay, a frame of reference is always referred to or associated with a time. Okay, the motion is described as the motion of a particle. We will say the body is in motion when, with reference to a fixed frame of reference, with the passage of time, it moves. Okay, or change its position. Absolute rest. Consider a frame of reference where all the bodies are not moving with respect to one another. Okay, then it will be called absolute rest. Okay, is there anything in the universe that is not moving at all? No, there is no such thing in universe. Everything is moving in universe, so there is no absolute rest. Okay, absolute rest is a condition of a body with respect to another fixed reference frame. It is not moving. At all. Okay? It is not moving with respect to a frame which is fixed. Is there any reference frame which is fixed? No, there is no a fixed reference frame. Everything is moving in this universe. So there is no absolute rest. Absolute, what is absolute motion? Absolute motion. Absolute motion or the motion of a body with respect to a frame of reference which is a absolute rest type. Is moving with the passage of time. Okay? So absolute motion is considered with respect to a frame of reference which is fixed or it is absolute rest. That frame of reference is absolute rest. Is there anything in this world, in this universe, which is a absolute frame of reference? No, there is no a absolute frame of reference. So there is no absolute motion. Okay? As there is no absolute rest in this universe, so there is no absolute motion in this universe. Okay? Every particle or a celestial body is moving with respect to one another, which is also moving in this universe. Okay, so there is no absolute rest or absolute motion. Reference frame. A reference frame as I have told earlier, a reference frame, everybody in this world is moving. So, in order to describe the motion of a particle, okay, motion of a particle, we have to choose a particular frame of reference. Okay, when we say the train is moving (54 km/h), okay, then what do you mean by this? The train is moving 54 km/h. That means with respect to the ground or with respect to the earth, it is moving 54 km/h. That ground or the earth is the frame of reference. Okay, we can choose any frame of reference. Suppose a body is A is moving in this direction. Okay, when we do not choose any frame of reference, then it is not worth to say A is moving in this direction, okay, with some velocity. Okay, so we have to choose a frame of reference. Okay, a frame of reference which can describe this motion. Okay, and a frame of reference has also a starting point, or it is called the origin. Okay, and this frame of reference can also be one dimensional, two dimensional, or three dimensional. When you say one dimensional, it will refer to a straight line motion. Okay, suppose a particle is moving in x direction. Okay, so it is not changing its direction. Okay, so it will be called a one dimensional motion. Okay, when the particle is moving in a plane, okay, in this case xy plane, let it is xy plane, then its motion will be called 2D. Okay, when the particle is moving not in a plane, okay, not in a plane, that is, it is moving in 3D. Clear? That is, it is moving in all direction, x direction, y direction, and z direction. Okay, an aeroplane is moving in the sky. Aeroplane is moving in the sky. It is three dimensional. A car moving in a straight line, or a free fall, or a body is falling towards earth. In case of free fall, it is one dimensional motion. Okay, and motion of a planetary motion is two dimensional. Planetary motions are two dimensional, and aeroplane motion is three dimensional. Okay, polar frame of reference. A polar frame of reference, let's say a Cartesian coordinate system. Okay, Cartesian frame of reference, it is 2D. Okay, when we describe the position of a particle with respect to x-axis and y-axis, let it is x and y. Okay, x dot y. Okay, it is a coordinate system. Okay, its projections are, this is x and this is y. Oh, sorry. Okay, this is y, this is x. Okay, then we can define this position from origin like this. Okay, and the magnitude of displacement will be, let it is b, OP is equal to x square plus y square root over. Okay, this is called 2D. Okay, this is called 2D. And if we describe the position of a particle with respect to x and y axis as r and theta, what is r? This is r. This is the position vector of particle A from origin, and it makes angle theta with the x axis. Okay, then this is base, this will be P, and this will be hypotenuse. Okay, then B is equal to r cos theta. Okay, P is equal to r sin theta, and tan theta will be P by B. Okay, tan theta is equal to P by B. Right? And this is called polar frame of reference. Inertial frame of reference. What is inertial frame of an inertial frame of reference is a frame of reference where Newton's law holds good. What does it mean? An inertial frame of reference is a frame of reference where Newton's laws holds good. Okay, or the first law holds good. Suppose a frame of reference is here, another frame of reference is here. Okay, when the two frame of reference are at rest or moving with uniform velocity with respect to each other, then these two frame of reference will be called inertial frame of reference. Okay, it is either two frame of reference, this two frame of reference is moving with same velocity, with same uniform velocity, or at rest. Okay, it is or at rest, it is A and B. Let A is a frame of reference and B is a frame of reference, then these two frame of reference will be called inertial frame of reference if A and B with respect to AB are at rest or AB are moving with uniform velocity. Okay. That means to say that with respect to A, the frame of reference B is not moving. Okay. Translational, different kinds of motion. What are the kinds of motion? Translational motion. Translational motion. What is translational motion? Suppose a body is moving in this direction. Okay. When a body A is moving in this direction, it can move either in a straight way or it may rotate slightly. Okay, it may rotate slightly and go forward. Okay, in this case, when it spins, rotates, the position of the particles also changes. Okay, in that case, it will not be a translational motion. Every particle moves in a straight line and that straight line do not cross each other. Okay, then this type of motion will be called a translational motion. Okay, the motion of these particles is parallel to each other. Okay, then this is called a translational motion. A straight line motion is a translational motion. Rotational motion. What is a rotational motion? If a particle moves in a circular path, with a axis at its center. Okay, if a particle moves in a circular path in a fixed axis, okay, this type of motion is called rotational motion. In case of rotational motion, there is a fixed axis around which the particle moves. Okay. And the complex motion is, what is a complex motion? A particle is rotating, also it is moving in a straight line. It is a mixed. Complex motion is mixed rotational and as well as translational. Okay, this type of mixed motion is called what? Complex motion. Now come to position. Position of a particle with respect to an origin of a frame of reference is the displacement okay, where let a particle is here, okay, how far it is from the origin describes the position of the particle, okay, let its position is xy, then it is x distance from origin, okay, x distance from origin and y distance from origin, okay, its displacement along x axis is x and y axis is y. So it is a vector quantity. Okay, it is a vector quantity. It has a direction. Okay. Do you know scalar and vector? Scalar quantities are those quantities which has only magnitudes, not directions. And vectors are both magnitude and direction. Okay. Displacement. Consider the particle is here, okay, or at origin O. This is x-axis and this is y-axis. Okay, it is at position O. It moved like zigzag manner, okay, and reached position B. In this case, the particle has covered a distance of A to B, okay, in this manner, okay. But displacement is a vector quantity which measures only the initial point and the final point, okay. Displacement is a physical quantity, is a vector quantity which counts only the beginning and the end point, okay. So if a particle starts from here and returns to the original position, its total displacement will be 0, whereas the distance traveled by the particle A is the total path covered by it. Total path means the total distance covered by it, okay. Always displacement and distance, always keep in mind that these are two different things, and distance covered is greater than displacement always, or equal, okay. Where it will be equal? If it is in a straight line motion. then in that case distance covered will be equal to displacement of the particle. Okay, always keep in your mind, this is very important. This minute difficulties, minute change or minute error, that is displacement in distance, will wrong your answer. Okay, so always displacement and distance are two different things. Speed, then come to speed. Speed is equal to total distance by total time. Okay, speed is equal to total distance by total time. Total distance covered, not displacement. If it is displacement, then it will be velocity. Always keep in mind. Okay, suppose a body starts from here and covers 50 kilometer in time interval 5 seconds. Okay, 5 seconds. This is time interval 5 seconds. Okay, then it will be speed will be 50 by 5. Then it speed means average speed. Okay, 10 km per hour. Okay, speed. What is average speed? Speed means average speed. Average speed is total distance by total time. Okay. Instantaneous speed. Instantaneous speed refers to the speed at a particular time. Okay, what is particular time? When the time interval becomes infinitely small, that is when del t tends to 0. Okay, then we will find the limit value of del x by del t. Okay, limiting value of del x by del t, that is rate change of distance with respect to rate change of time. Okay, when the del t is very small, that is del t tends to 0, this becomes dx by dt. Okay, this will be instantaneous speed. Okay, let the speed of a particle described by x is equal to 3t square. Okay, the position of a particle described by x is equal to 3t square. Okay, what will be the instantaneous speed? Dx by dt is equal to d by dt 3t square is equal to 60. Okay, its instantaneous speed is equal to 60. When t is equal to 2 seconds, its speed will be bar 12. So it is the instantaneous speed at a particular time. What will be the speed of that particle? Okay, look at the speedometer of a biker. At a particular time, it indicates 50 km. That is the instantaneous speed. Okay. What is velocity? Velocity. Velocity is equal to displacement by time. Displacement upon time. Look what, this is displacement, not distance. Velocity is displacement by time. Okay. Suppose a body starts from here 0 and it go up to B, it is 5 km at time 2 seconds. Then what is the speed of velocity of the particle? Velocity of the particle is 5 km per 2 seconds. It's equal to 2.5 km per second. Okay. Velocity of a particle, velocity is a vector quantity. Okay, it is a vector quantity. As displacement is a vector quantity, velocity is also a what? This is also a vector quantity. So it has a fixed direction. Okay, it may be positive, negative or 0. Okay. Uniform velocity. What is uniform velocity? Uniform velocity when a particle covers equal distance in equal interval of time. What do you mean by that? Suppose a particle is at position A. Okay. Then in 1 second it covered 5 meter. Okay, in another 1 second it also covered 5 meter. Okay, and also in another 1 second it covered 5 meter. In that case the velocity is uniform, as the distance covered by the particle in equal interval of time is fixed. Okay, then the particle is said to be in uniform velocity. If the particle covers equal distance in equal interval of time, okay, then the particle is said to be in uniform velocity. Average velocity is, what is average velocity? Average velocity. Average velocity is total displacement by total time. Okay, total displacement, total time. Then instantaneous velocity. So in the case of instantaneous speed at a particular time. So instantaneous velocity is velocity of a particle at a definite interval of definite time. Okay, then limit del t tends to 0 del x by del t is equal to dx by dt. This position describes, this is derivative. Okay, this position describes the instantaneous velocity. Okay, and problem based on this will be discussed later.